As always, please pause the video and try the question on your own before listening on. To solve this question, what we need to do first is draw a free body diagram for mass m and also a free body diagram for mass 2m. For the mass that's labeled m, we have several forces acting on it. We have the gravitational force that's acting downward, which we've labeled as mg. We have the surface of the ramp pushing up on the mass, and that's called the normal force. And then we'll notice from the diagram that the mass labeled m is connected to two ropes. One is labeled T1 and the other is labeled T2. T2 is trying to pull the block down the ramp, whereas T1 is supporting the block so that it doesn't fall down the ramp. So we've labeled those forces accordingly. The free body diagram for block 2 is similar, but it has some important differences. The gravitational force is now labeled as 2mg since the mass of that block is 2m. That block is only attached to one rope, and that rope is preventing that block from sliding, so there's a force acting up the ramp. We've labeled that T2. And then, of course, the surface of the ramp is pushing up on the 2m block, so we have another normal force. As with all free body diagrams, what we want to do next is take any force that's acting at an angle, such as mg, and break it into its x and y components. So we're going to do that for mg and also for 2mg, because both of those forces are acting at angles. So for the y component of the mg force, we would have mg cosine theta. And then for the x component, or the component that's parallel to the ramp, we would have mg sine theta. If you have any questions about where those components are coming from, please let me know in the comments. We've done a similar analysis for the other free body diagram. Once we break the mg force into its x and y components, we want to eliminate the fg resultant from the diagram. So we're going to take out mg and we're going to take out the 2mg. And we're only going to leave behind their components, because it turns out that when we go to the later analysis, we only want to be working with components. Next, we will apply Newton's second law for both blocks. Now, we know that both blocks are in equilibrium. How do we know that? Well, because they're just sitting at rest on a ramp. They're not accelerating. And we recall that when an object is not accelerating, that the sum of the forces will equal 0. Now, what we can do for block 1 is just sum the forces in the x direction. We notice that there are a few forces acting in the x direction. We have T2, which is pointing sort of down the ramp, and we can call that the positive direction. We have mg sine theta, also which is pointing down the ramp. And then we have T1, which is pointing up the ramp and will therefore be negative. Let's plug those into the sum of the forces. And then we can add T1 to both sides of the equation. And we can see that T1 is equal to T2 plus mg sine theta. That's a result that we're just going to hold on to. Let's next turn to block 2. We're going to erase this free body diagram in the middle just to clear up some space. For block 2, as with block 1, the sum of the forces in the x direction will equal 0. There are only two forces acting in the x direction. We have 2mg sine theta. That's pointing down the ramp, so we'll call that the positive direction. And then we have the tension T2 force acting up the ramp, and we can label that as the negative direction. So let's fill in the forces. And just like with block 1, we can add the T2 over to the other side. And we find that T2 is equal to mg sine theta. What we'll do is we'll substitute this expression for T2 over in the T2 from our first equation. And after making that substitution, we have these like terms. We can add 2mg sine theta plus 1mg sine theta to make 3mg sine theta. So that'll be the correct answer for T1. And then, as we had just found a moment ago, T2 is simply 2mg sine theta. So we have accomplished our goal, because the question said in terms of m and theta. And notice that T1 is indeed in terms of an m and a theta. It's also in terms of g, but that's fine. T2, again, is in terms of m and theta. Thanks again for taking the time to watch this video. If you'd like to, please subscribe so you can stay tuned for additional videos. You are also welcome to send in your own questions to the email address on the screen.